Hello everyone. Next, we will study a study of rivers and groundwater, the vast bodies of water on the Earth's surface under solar radiation. A large amount of water is evaporated and rises into the atmosphere. This moisture is then transported to various regions by air currents. During the process of rising and transport, water vapor condenses under certain conditions in the form of precipitation, falling onto land or ocean surfaces. Rainfall on land creates surface and subsurface runoff, which flows into the oceans via rivers. It then evaporates from the ocean surface once more. This cyclical process of water movement is known as the natural hydrological cycle. Evaporation, condensation, precipitation, runoff, and infiltration are all major stages of the water cycle. The water cycle provides humanity with abundant water resources, including river runoff, groundwater, lake water, swamp water, seawater, glaciers, etc. In this chapter, we will focus on four main topics: 1. Understanding rivers. 2. Learning about the geological effects of rivers. 3. Understanding groundwater. 4. Engineering geological issues related to groundwater. Next, we will first study the understanding of rivers. In addition to infiltration and evaporation losses, rainwater falling to the ground flows under the action of gravity along a certain direction and path. This water flow is termed surface runoff. Over a long period of time, surface runoff erodes the ground, carving out gullies and forming streams that eventually come together to form rivers. Rivers can be divided into the following sections: source, upper course, middle course, lower course, and mouth. Generally, the upper course of a river is characterized by a steep drop, rapid flow, and narrow valleys, with numerous rapids and waterfalls. In the middle course, the gradient lessens, the river channel widens and meanders, and there are shoals along the banks. Conversely, the lower course features a wide river valley with a slow current and significant alluvial deposition in the channel. Shoals and sandbars are common, and meanders are well developed. A system composed of interconnected rivers and streams of various sizes is called a drainage system, river system, or river network. A drainage system is typically named after its main stream. Within a drainage system, a river that flows directly into an ocean or a lake is called a mainstream. A river that flows into the mainstream is called a first-order tributary. A river that flows into a first-order tributary is a second-order tributary, and so on, by analogy. So, what are the characteristics of different rivers? And what characteristic values are used to calculate and determine these features? We will now explore this further. First, there is a sinuosity coefficient. It expresses the degree of curvature of a river S-shape in plan view. It is the ratio of the total length of the river channel to the straight line distance L between the source and the mouth. The greater the sinuosity coefficient, the more sinuous the river. Next is the longitudinal gradient of the river. The profile along the thallweg of a river channel is called the longitudinal section. The longitudinal gradient is its numerical characteristic. When the river S longitudinal section is nearly straight, the longitudinal gradient is calculated by the following formula. Rivers with a steep gradient have a high flow velocity and a strong erosive power. Conversely, rivers with a gentle gradient have a low flow velocity and frequently experience sedimentation. We know that different rivers have different characteristics, and different rivers are often formed by rainfall collected from different drainage basins. Next, we will learn about the characteristics of river basins. Where the terrain slopes on both sides, when the terrain slopes away on both sides, causing rainwater to flow into two different rivers respectively. The ridgeline of this terrain acts as a watershed and is known as a watershed line. The area that collects surface water and groundwater, that is, the area enclosed by the watershed line, is what we call a drainage basin or watershed. Whether the surface and subsurface watershed divides coincide is crucial for determining if a drainage basin is closed. In karst regions, there are often many non-closed drainage basins. The drainage basin area refers to the horizontal projection area of the surface catchment. It is an important indicator for gauging the size of a river. When other conditions are the same, the magnitude of F determines the volume of river runoff. Typically, the water volume of a river increases progressively downstream from the source to the mouth, but precipitation distribution becomes more uneven. Drainage basin shapes can be classified into fan-shaped and feather-shaped basins. In a fan-shaped basin, runoff from different directions converges centrally, making it easier for large runoff volumes and floods to concentrate. In a feather-shaped basin, tributaries from both banks join the main stream alternately. Runoff volume changes are small, and floods are less likely to concentrate. Through the learning in this lesson, we have learned about the formation and characteristics of rivers and their drainage basins. Please complete the exercises carefully. Next lesson, we will study the geological effects of rivers.